So welcome to this latest video on 162 Maths. In this video we'll be going over some GCSE Maths higher exam questions related to volume of spheres and cones. Now as always there'll be a copy of the questions that we go through in this video as a link in the description for you to download and have an attempt at before watching these videos so you can test your prior knowledge. I'll also include some links to lessons that cover this topic in more detail, so if you're unsure about any aspects of this topic I strongly recommend you watch that lesson first before practicing some exam questions. Now before we get started working through some questions, let's just have a quick overview over this particular topic. Now in terms of what you need to know, you kind of need to know the formulas. Now the formulas on GCSE exam papers are going to be given. They're not going to be given on the actual insert or the formula sheet. It's actually going to be given within the question. Now the formula that they give you may be or may not be the formula that you actually need. So for example, they may give you the volume of a sphere but actually you're dealing with a hemisphere, and they may give you the volume of a cone when really you're dealing with the volume of a frustum. So again, just be mindful that they will give you the prompts for the formulas, but you then need to know how to manipulate those formulas to work with different shapes. Now the formula for the volume of a sphere is 4/3 and then it's pi and then it's r cubed. Then for the volume of a cone, the formula is 1/3 times pi times the base radius squared times the perpendicular height. Now the perpendicular height is this length here, so that's h, and the radius is this here. So hopefully you can see a link in the fact that this may involve Pythagoras. So again, it's really important that you know the formulas, be aware of them, know how to differentiate between the two, but again they will be given to you in the exam, so just be mindful of that. But if you're doing an internal exam, then there is a chance that your teacher might forget, or whoever's writing the test paper might forget. Another type of thing that you need to know is reverse questions. So reverse questions are when you're given the volume and you want the radius or the height or the diameter of the base or the sphere. So again, just be mindful of that. Another thing you need to know is to work with compound shapes. Now compound shapes are basically where you've got two shapes joined together. So for example, you could have a hemisphere on a cone, or again you could have a frustum. So again, we've got a cone, two cones in for that one. So just be mindful of practicing those, and also practice questions which involve leaving your answer in terms of pi. Now this, once you've substituted the values in, will involve some algebra manipulation. Now the connected topics to volume of a sphere and cone include Pythagoras, they include compound units, so looking at force, density, etc. You're also looking at looking at converting units as well. Sometimes your height might be given in meters, but the base might be in centimeters. So again, when working in the volume, you need to make sure that all the units are the same. Also links with surface area, fractions, again with fracture calculations, because obviously as you can see the formula involves, well, for a sphere it involves 4/3 and for a volume of a cone it involves 1/3, but you can see no other terms involve a fraction. So another way of writing the formula is to write 4 pi r cubed all over 3. Another way of writing the volume of a cone is pi r squared h all over 3. So that eliminates the need of multiple fractions, but again just be mindful of different ways of doing it. Also involved in this particular topic is solving, a knowledge of solving equations, and this could involve quadratics, it could involve linear equations. Algebraic fractions, again if you've got quite a complex question which doesn't give you the radius and doesn't give you the height, gives you an algebraic expression. So for example, where the radius is just r and the height might be 2r or 3r or 2x or 3x, etc. And also obviously simplifying as well. So you need knowledge of being able to simplify expressions, writing common denominators, which again will be covered in the questions that we go through in this topic test. Before we get started, a little reminder that if you're wanting access to these questions, all you need to do is just simply click on the link in the description and you'll have access to them. Alternatively, you can simply pause the video, have a go at the question, and then unpause as we go through the answer. Now if you're wanting again more in-depth teaching of this particular topic, then I strongly recommend that you give the lesson a quick watch through just to get some understanding of what it is that we're actually doing, in case that what we're doing is a bit too fast, a bit confusing, and you could do it at a little bit slower pace. So again, strongly recommend you check out that video that goes through it in more detail. So let's get started on question 1. So question 1 says, here is a sphere, and it says the volume of the sphere is 36 pi, work out the value of r. And as you can see, we're given the volume of the sphere. So all we need to do here is substitute v equals 36 pi. So here we've got 36 pi equals 4/3 pi r cubed. Now, as I mentioned, one way that you might want to rewrite this formula here is to write it so it's all over 3. So for example, if I just move over here, so if I write 4 pi r cubed all over 3 equals 36 pi. Now, straight off the cuff, what I can do is both sides have got a pi, so I can cancel that out. And I can take the 3 over to the side, so I end up with 4r cubed equals, and it's going to be 3 times 36, which 3 times 36 is going to give me 108. Then if I divide by 4, I'm going to get an answer of 27, and 27 is a cube number, so r is going to equal 3. Then moving on to question 2, it says here is a cone, and again we've got the formula for the cone, which is nicely given to us, and it says work out the volume of the cone, give your answer in terms of pi. So here you can see that I don't know the height, so I know that the radius is 3, but the height is a bit of a question mark. So if I take this triangle out, so let's just draw a triangle like so, and if I take that triangle and just redraw it outside, so this is 3, this is 5, I'm going to call this h. So I can use Pythagoras to work this out. Now h is the smaller side, so it's going to be 5 squared minus 3 squared. So h squared equals 25 minus 9. So h squared equals 16. So h is going to equal 4. So now that I know that h equals 4 and r equals 3, I can substitute that into the formula. So v equals 1/3 times pi times 3 squared times 4. So simplifying all of this, I get v equals, and then again I've got pi times 9 times 4 over 3. So that's going to be 36 pi over 3, which simplifies to give me 12 pi. So volume is going to be 12 pi. So moving on to question 3, it says here is a sphere and a cone. The formulas of their volume are shown. The radius of the sphere and the radius of the base of the cone are both r. The volume of the cone is half the volume of the sphere. Work out the height of the cone in terms of r. Now, looking at this bit of information, which is probably the most important bit, now there's two ways in which you can interpret this. Now it says that the cone is half the volume of the sphere. So the cone is the smaller shape, and the sphere is the bigger shape. So that means that either, how to work this out, either the volume of the cone times 2 equals the volume of the sphere, or you know that the volume of the cone equals the volume of the sphere divided by 2. Now there's two ways in which you can write the initial statement. So you can either write this or you can write this, and it really does depend on how you see it. So if I just call this one number 1 and let's call this one number 2, and I'll show you how both would still give you the same answer. So using number 1, we know that 2 lots of the cone, so it's going to be 2 times 1/3 pi r squared h equals, and this is the cone, and the sphere is going to be equal to 4/3 pi r cubed. Now using this method, then what we can then do is, well, expanding it out, I get 2/3 pi r squared h equals 4/3 pi r cubed. Now, cancelling what both sides have got, well, I can take away the 3 because we're divided by 3 by both sides, and I can cancel a pi, and I can also cancel 2 r's. So I'm left with this. So what am I left with? Well, I'm left with 2h equals 4r. So therefore, making h the subject, I get h equals 4r divided by 2, which equals 2r. So h equals 2r. Now, if I was to use the second method, so let me just move the second method over here. So then the volume of the cone, which is 1/3 pi r squared h, and this is number 2, and that's going to equal the volume of the sphere, which is 4/3 pi r cubed divided by 2. So then simplifying each of these, what we end up with is pi r squared h divided by 3 equals, now for this all I need to do is just move this denominator to the bottom, so that then becomes 4 pi r cubed over 6, and then all I then need to do is just then go on and simplify. So from this I could cross multiply, so I end up with 6 pi r squared h equals 12 pi r cubed. Then if I then start cancelling out, so I can cancel pi, I can take off 2 r's, and what I'm left with is 6h equals 12r. And again, making h the subject, I get h equals 12r over 6, which equals 2r. And as you can see, gives me the same answer. Moving on to question 4, it says that a small toy is made by joining a solid cone and a solid hemisphere together. The cone and the hemisphere each have a radius of 3, and it's got the height of the total shape, which is 15. It says show that the volume of the toy is 54 pi. So let me just zoom out so we can see all of this question in all its entirety, and I'll do the work on the side. So recognizing, let's just label the shapes. So I've got the cone as shape A and the hemisphere as being shape B. So working out the volume of A, well, that's just a straightforward cone, so that's going to be 1/3 times pi times the radius of that cone, which is 3, so it's going to be 3 squared, times the height of that cone. Well, the hemisphere is going to have a consistent radius, so that's also going to be 3. So if all of it is 15, this bit is 3, then that means that the height of the cone must be 12. So that's going to be times 12. And if I work that all out, I get pi times 9 times 12 divided by 3, which gives me an answer of 36 pi. Then if I work out the volume of B, which is a hemisphere, now note how the formula gives me the volume of a sphere, so then the volume of a hemisphere would be 4/6 pi r cubed. So it's going to be 2/3 times pi times 3 cubed, which gives me 2 times pi times 27, all divided by 3, in which the 3's cancel, or I can cancel the 3 with the 27, so that becomes a 9, so that then leaves me with 18 pi. So all that's left for me to then do is work out the total volume, which is going to be 36 pi plus 18 pi, which gives me an answer of 54 pi. Then moving on to question 4b, it says that a larger version of the toy is made and has dimensions twice the size of the small toy and a mass of 0.5 kilograms. The toy is made from foam. Work out the density of the foam. Give your answer in grams per cubic centimetre. Now, density is basically mass over volume. So what I need to do to work out the density, I need to work out the mass in grams, and I need to work out the volume in cubic centimetres. Now, in terms of this bit of information here, I know that the length scale factor is 2, so that means that the volume scale factor is going to be 2 cubed, which is 8. Now the volume of the toy, or the small toy I should say, was 54 pi. So then the volume of the large toy is going to be 54 pi times 8, which gives me an answer of 432 pi. So then, and that's in centimetre cubed. So then I need to work out the mass in grams. Well, it's told me that it's 0.5 kgs. So that in grams is 500 grams. So that means that the density, therefore, is going to be 500. Let me just write that 5 a little bit better. So it's going to be 500 divided by 432 pi. And typing that all into my calculator, I get an answer of 0.368, and that's in grams per cubic centimetre, and that's to 3 decimal places. And the units are given to me, so and if I didn't write that, it would have been fine. Moving on to question 5, it says that this right circular cone has a radius of 3p and a height of 8p. The dimensions are in centimetres. It gives me the volume of a cone, and it says the volume of the cone is 12,288 pi cubic centimetres. Work out the value of p. So let me just zoom out so we can see all of this. So what I've then got is a third times pi times the radius times, radius squared times h equals 12288 pi. Now the radius is 3p, so that becomes a third times pi times 3p squared, and the height is 8p, so times 8p, and that equals 12288 pi. Now straight off the cuff, what I can do is, if I simplify the 3p squared, so I've got third times pi times 9p squared times 8p equals 12288 pi. Then simplifying all of this, the 3 I can cancel out with the 9. So then that leaves me with 3 times 8, which is 24 pi p cubed, and that is equal to 12288 pi. Then I can cancel out the pi from both sides. So then p cubed is going to equal 12288 divided by 24. So then if I then do the cube root of that, we'll work out the value of the fraction. So that gives me p cubed equals 512. So p equals 8. Then moving on to question 6, it says that the sphere has a radius of x centimetres, a cone has a base of y centimetres and a height of 2x centimetres. The shapes have equal volume. Work out the value of y over x. Give your answer in the form of root k, where k is an integer, and it's worth 3 marks. So first of all, let's work out the volume of the sphere, which is going to be 4/3. Oh, what's happened there? So it's going to be 4/3 times pi times x cubed. And then I can then work out the volume of the cone, which is going to be 1/3 times pi times y squared times 2x. Now try and make sure that your x's don't get confused with the multiplication x's. I know what I'm writing, but again, very easy to make a silly mistake when writing all of this. So then if I join these two things together, so here I've got 4/3, well, if I write 4 pi x cubed over 3 equals, and it's going to be pi y squared 2x over 3. You can see how both of them are divided by 3, so I can cancel that out. I can take out the pi from both sides, and I can take an x from both sides. So then all I'm left with is 4x squared equals y squared times 2. So that's going to be 4x squared equals 2y squared. So then if I then start looking at y over x, so I take the x squared over to this side and the 2 over to the other side, I end up with 4 over 2 equals y squared over x squared. 4 over 2 is 2, and I can then square root, well, that's going to be y over x squared. So then all that's left is to square root both sides. So y over x equals root 2. Then moving on to question 7, it says that a bowl is a hemisphere with a radius of 12. Water fills 1/3 of the volume of the bowl. The water is poured into a hollow cone and the depth of the water of the cone is 18 centimetres. So then it tells me the formulas as per given in most questions, and the question is asking us to work out the radius of the surface of the water in the cone. So going back to the question, what it's asking me to do is to find this value here. Now again, looking at this, what we need to do is probably just zoom out and let me do the question on here. Apologies if it's going to be a struggle to see, but hopefully you've made a note of the question. So looking at this, the first thing we want to do is work out the volume of the hemisphere, which, looking at the volume of the formula that's given, it's giving me the volume of the sphere. So that's going to be half of that. So it's going to be either, well, it's going to be 2/3 pi r cubed. So we know that the radius is 12. So then what we've then got is 2/3 times pi times 12 cubed. And if I work that out, I get an answer of 1152 pi. Now in terms of the amount of water is 1/3 of that, so it's going to be 1/3 times 1152 pi. And that gives me an answer of 384 pi. And I'm going to work with pi because it's decimal numbers and I want to try and keep it as accurate as possible. So that's how much water there actually is. Now that's what the volume of this cone is going to be. So here, working with the volume of the cone, which I know is 384 pi, and the formula for the volume of a cone is 1/3 times pi times r squared times h. Now I know that the volume is 384 pi equals, I know that the radius is what I'm trying to find, so I can write that's r squared, and I know that the height of the cone is 18, and that's all divided by 3. So then what I can then do is simplify the 18 and the 3, so that becomes 6. So what, and take out the pi, so then I've got 384 equals 6 r squared, divide by 6, and I get an answer of 64. And so if r squared equals 64, r is got to equal 8. Then moving on to our last question, it says that the volume of a cone is 1/3 pi r squared h, where r is the radius and h is the perpendicular height. It says a cone has a horizontal base of a radius of 6 and a height of 21. The cone contains water of a depth of 14 centimeters. Work out the volume of the water, and it says give your answer in terms of pi. So let's have a look at this particular question. Now, what you can see here is actually I can actually see two cones. Now, what I'm wanting to do is work out the volume of the frustum. Now, some may know the volume of that it does have a formula, but I'm just going to go through how you'd work this out if you didn't know what the volume of a frustum is going to be. So looking at this, I can see I've got two cones. So I've got that smaller top cone and I've got the actual big cone. Now looking at this, I can see that the big cone has got a height of 21. And to work out the height of the smaller cone, well, if the frustum has got a height of 14, 21 take away 14 means that it's going to have a height of 7. So that means that the scale factor of the length is going to be 21 divided by 7, which is 3. Now, from this, what I can then do is work out the radius of that smaller cone. So here, if the big cone has got a radius of 6, then the small cone is going to have a radius of 2, because the scale factor is that the big cone is 3 times larger than the small cone. So from this, what I can then do is work out that the volume of the water is going to be equal to the volume of the big cone minus the volume of the small cone. So then, working this out, the volume of the big cone has got a radius of 6 and a height of 21. So substituting those numbers in, I get 1/3 times pi times 6 squared times 21. And that's going to give me an answer of 252 pi. Then working out the volume of the small cone, remember we need to work in pi. That's going to be, well, the small cone has got a radius of 2 and a height of 7. So it's going to be 1/3 times pi times 2 squared times 7, which gives me an answer of 28/3 pi. So then all that's left for me to then do is take away these two volumes. So then the volume of the water is going to equal 252 pi minus 28/3 pi, which, if I join together, is going to, by giving me a common denominator in terms of a fraction. So for example, if I then do 252 times 3, that's going to give me an answer of 756. So it's going to be 776 pi over 3. So that's what an equivalent fraction is going to be. So 756 take away 28 is 728 over 3 pi, and there is my final answer. And there we go.